thought it would be helpful to do some of these problems on the review together. The test has a matching bank just like this. In fact, it's just a shorter version. The questions are the same. They're just not all of them on the test. So like a dot, wouldn't that be point? And like it said here, answers are used more than once. So I'm not going to cross them off. But I noticed that point is E. Flat goes forever in all directions. That's a plane. Has two endpoints, a piece of a line. That's a segment. A line is straight and goes forever in two directions. That's a C. A ray, F, is what starts at one point, goes forever in one direction. These two are really important questions. 2 points make a C line, and 3 points that are non-collinear always determine a plane. And those are the ones that are repeated. Points on the same line, of course, are collinear versus on the same plane is coplanar. 2 points cross in a, 2 lines cross in a point, it's repeated, and 2 planes cross in a line, repeated again. 2 lines that never intersect are called parallel. Where's that? OI, yep, parallel. Segments with the same length, those are congruent. The idea of 2 little segments adding up to the big segment is segment addition. 2 little angles adding up to the big angle is angle addition. If I'm changing turn to degrees, I times by 360. If I change degrees to turn, I divide by 360. Of course, that 90 degrees, you know, is a right angle. Less than 90 degrees is an acute. More than 90, less than 180 is obtuse, and exactly 180 is straight. We use degrees to measure angles. That's M. The instrument we use is a protractor, and the sides, that's another important one, the sides of an angle are rays. Perfect. Okay, how many endpoints are on a line? Tricky. There's none. Segment has 2, ray has 1, but line and plane have no endpoints. We never use 3 letters. Common error on the test. We always use 2. When you name a ray, the endpoint goes first. If you have 1 point, you can really draw an infinite number of lines, but if you have 2 points, you can only draw 1 line. Now we look at the picture here, and it says name 2 different rays that go through point A. So like ray BA and ray CA both go through point A. If it has an end point of A, now it's going the other direction, like AB, AC would go the other way. Listing 3 points would be A, B, and C, but we know that there's an infinite number of points on the line. 3 segments might be like AB, AC, and BC, with AC being the longest. 3 different ways to name the line would be the same letters, AB, AC, BC, but now with a line symbol over them. Now we switch to this picture of the plane. Name the plane in 2 different ways. You could either say plane ABC, or you could say plane P. At least 3 points on the plane, of course, are A, B, and C, but those are only 3 of an infinite number of points on the plane. Switching pictures again, are these the same segment, M-A-A-N? No, they're not the same. But if I said line A-N, line M-A, yes, those are the same. It's hard to tell these arrows here. This is ray M-A, ray A-M. Those are not the same. But if I say ray N-A, ray N-M, those are the same. Where do these lines cross? New picture again. D-E, D-B here and E-F here. Those look like they cross at C. F-G, I'm going to erase it so I can see it again. There's F-G and C-D. Let's see. F-G and C-D. Those cross at B. Right? You can just trace them with your finger. E-D here and C-F here. Those cross at E. And then B-F, which is this one, and E-D, which is this one, those never cross. So they're parallel. And that's the name for 2 coplanar lines that do not intersect, parallel. Are B, C, and D collinear? Are they on the same line? B, C, and D, yes. What about C, F, and D? No. These planes here, R and S, they intersect right here at line A. And I would have to say line A. Same thing for U and T. Those intersect at line D. R and T intersect at line B. It's hard to read there. And then R and U, these don't intersect. They're parallel. 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 Okay, next picture, the plane that contains lines A and B looks like plane S. And then the intersection of planes P and S is this line here. I'm going to call it line A. It's the easiest way. Intersection of two planes is always infinite number of lines. Let's see, K, F, D, Q, are those coplanar? Yes, let me think, K, F. Oh no, sorry, those are not coplanar, but the other ones are. Those are tricky. Okay, yeah, next one. Use your ruler to the 10th of a centimeter. I actually don't have my ruler with me, so I'm going to have to skip those. And I don't think there's one like that. I can't remember. You know how to measure, though, I know. From N to Q there is just 4 plus 22 or 26. Here I'm going to subtract 40 minus 25 or 15. Here I'm going to add these up. So 2x and 5x is 7x, and 3 minus 1 is 2. Same thing here. I'm going to add these up. 7x and 2x is 9x minus 12. Now I'm going to have to subtract 2x plus 2 minus x is just x plus 2. And then this one's the hard one, 5x minus the quantity 3x minus 4. When I distribute that, I get 2x plus 4. Now I'm switching to equations. So the equations say the two little segments add up to the big segment. So 3x is 27 or x is 9. Here, if I combine like terms, I get 5x plus 2 is 32. So 5x is 30, so x is 6. And the last one here, if I combine like terms, I get 10x minus 3 equals 8x plus 9. That's letters on both sides. When I move things over, I get 2x is 12, so x is 6. Congruent means equal, and you can see how they're marked. So the segment AB here is congruent to segment EF, and then the other congruent pair is XY is congruent to JK. Don't forget the segment bar. I don't have a protractor to measure the angles. I'm sure you know how to do that. If it's an acute angle, you do the small number. If it's an obtuse angle, you do the big number. Here it's just reading the numbers right off the picture. So PRT is 81 degrees, TRS is 42. VEZ in there is 23 degrees, REU is 24 degrees, and VEU is 30 degrees. Reversing it and writing it on the picture, YZX there is 10 degrees, and the other one here is 50 degrees, so the whole thing is 60 degrees. Here we've got vertical angles, right? 110, 110, and then these two are 70 and 70. Is LKJ acute or right? LKJ here, that's obtuse it looks like. JLK, that little one is acute. MKL looks right, and JML is straight. Angles that are congruent, angle A is congruent to angle C, and angle B is congruent to angle D. Similarly here, angle L is congruent to angle M, and angle P is congruent to angle N. Here, when we put them in the picture, our SP there is 20, PST is 30. We're going to add those together for the whole thing is 50. Versus here, they give you the big ones 120, the little ones 35. If I subtract those, I get 85. TOR is a straight angle, or 180. If this guy is 150, we subtract and get 30. Last page here, 15 degrees is this little one right here. The whole angle is a straight line, or 180. So if I subtract there, 165. Here, the whole angle is a right angle, or 90. The little one here is 23, and if I subtract, I get 67. Similarly here, it says RQS is 57. The whole thing is 90. 90 minus 57, 33 degrees. Expression, we're going to add those up, so we get 18x plus 9. Here we're going to add these up, 12x plus 6. equation here, the whole angle is a straight angle, which is 180. If I add those up, I get 14x minus 2 equals 180. So 14x is 182. And if I divide that, I get 13. Then I have to go back and plug that in. So 13 plugged in there is 130 minus 5, which is 125. And 13 plugged in here is 55 degrees. Similarly, the whole angle here is 90 degrees, a right angle. When I combine my like terms, 3x minus 2 equals 90. So 3x is 92. Oh, yeah, minus 2. Yeah, 3x minus 2. So 92. I'm just like, that doesn't go in even. I made a mistake. It wasn't 3x, it was 4x. So 4x minus 2 is 92. That's better. So x again turns out to be 23. Again, if I plug that in, 23 minus 4 is 19 degrees. And then here, 23 times 3 plus 2, 71 degrees. The last thing is changing turn to degrees, right? Changing turn to degrees. So 1/4 you multiply times 360 is 90 degrees. Half of 360 is 180 degrees. 3/4 would be 3 times 90, right, 270 degrees. 7/12 times 360, this is going to be, what, 210 degrees. And you could do these on a calculator. Times 360, 72 times 4 is, what, 288 degrees. And then 4/9 times 360, that goes in 40 times 160 degrees. Going backwards, you might have some of them memorized, like 180 degrees is half a turn, but the ones you don't know, we divide by 360 and reduce the fraction. So if I divide both by 4, I get 2/9 of a turn. 135 over 360. If I divide top and bottom by 5, sometimes like I just start with that. So that would be out of 72 on the bottom. 5 goes in there, what? 25 times, is that it? 135 divided by 5, 27 times, there you go. And then if I divide that by 9, I get 3/8. You could put this on your calculator, it'd probably be a ton easier, right? And then just reduce the fraction on there. 12 goes into 144 12 times 30, and then if I divide by 6, 2/5 of a turn. 150 over 360, if I cross out the zeros and then divide by 3, 5/12 of a turn. And then 300 divided by 360, 30 over 36 would be 5/6 of a turn. Boy, these last ones are hard to read, aren't they? Which statement about the figure is true? The first one. Oh no, they don't intersect at point A, they intersect at point E. A, B, and C are not collinear. E, C, and E, D are opposite rays. That's true. They go in opposite directions. 3 points that are collinear on the same line looks like G, H, and I. The intersection of plane HGY, that's like this one in the front, and HFX on the side, this is going to be HZ here, so that's B. The acute angles, let's see, the acute angles, the cute little ones, look like CAD and DAE. I would say that, A. The length of XZ just adds those together, so C. If MPN is 85, what's X? So if I add those up, I get 14X plus 1 equals 85. 14X is 86. X is going to turn out to be 6, no, 7, no. I made a mistake. It should have been 14x equals, subtract 1 from both sides. Hello, 84, right? So then it's 6. B. Which line is not drawn? Let's see. EC, AC. I think this one, FD, is not drawn in there. It's still a line, but it wasn't drawn, right? Collinear points are all in a row, so A, E, and C. And then the intersection of AC and BD would be point E. So there you have it, Chapter 1 review.